Wow, I can't believe you're here. Thanks for being here. Let's practice some word problems with systems of equations, huh? All right, we got a Joker sheet. Let's do what are there, 5 problems on this sheet? Oh my gosh. Set up and solve a system of equations for each scenario. Discover the rest of the joke by writing the letter that matches your answer on the corresponding blank line above. So the first one, Carrington Ivy the Fourth needed Jello and tuna for what he was calling the party of the century. He went to the store and bought 6 pounds of Jello and 2 pounds of tuna for $18.30. That's probably going to be pretty important. Turns out it wasn't enough of either, so he had to return to the store and get 5 more pounds of Jello and 7 more pounds of tuna for $24.85. Find the cost of a pound of each item. Now, to me, these are like the easiest things to set up. It's like once you figure out the pattern with these, it's pretty easy. Like 6 pounds of Jello. If each pound of Jello was $1, and you said, well, how much would that cost? You would do 6 times the dollar, right? We don't know how much it costs, but really we could use any variables we want. So if I see 6 pounds of Jello, I'm going to say 6J. Plus, I'm also getting the 2 pounds of tuna. So I'm going to say plus 2T. And I'm going to use a capital T because my lowercase t's just look like plus signs. For a total of $18.30. Great. That's it. That's how we set up every equation. The other time I went and I got 5 pounds of Jello, 5J, plus 7 pounds of tuna, and that was $24.85. That's the only difference. We just have to set up the two systems. Now I'm going to move all the way over here. Okay? And remember, we need either the J's to match up or the T's to match up. It truly doesn't matter which one you do. I'm going to do the T's. 2 and 7 both go into 14, so we would multiply the top by 7, the bottom by 2. And with elimination, I find it easier if you have one positive and one negative. So we can fix that right now and just do multiply by -2, and then that'll come out to -14t. So the top line times 7, 7 times 6j is 42j, plus 7 times 2t is 14t, equals, I don't know what 7 times 1830 is, $128.10. Now the other line, we're multiplying by -2, so that would be -10j, -14t, and 2 times 24.85, -49.7. Now, if we were to use elimination, 42j minus 10j is 32j. Our tuna has been eliminated. And then let's see, 128 minus 49.7 is 78.4. $78.40. Now we are going to divide this by 32 to get the cost for 1 pound of Jello. J equals 2.45. So $2.45. So I'm going to come over here and I'm going to say the Jello's $2.45. Oh gosh. But we need to figure out the cost of the tuna. It's too much tuna. So we have 4 equations to choose from. The first 2 are typically the easiest. They're just smaller numbers. So, I'm going to go with the first equation, the 6j. So we have 6 times the pound of Jello, which we know is $2.45 per pound, plus our 2 pounds of tuna, came out to $18.30. 6 times 245 is 14.7. So $14.70 on Jello. It happens. How are we going to get rid of that 1470? We're going to subtract it from 1830. which means 2 pounds of tuna came out to $3.60. We got it divided by 2. Half of $3.60 is $1.80. So the tuna was $1.80. Now, with word problems, you don't need to write it as a coordinate. You could set it up like an XY thing. If you were to graph it, you can see where they intersect. But let me make sure those are good. All right, 245, bone 80. Sweet. You got this, man. There's 4 more scenarios for you to solve, I believe. Yep, 1, 2, 3, 4. You got this. Oh my gosh.